So we are going to graph this rational function. Just a nice sketch. This is a slightly more complicated one. At least it looks slightly more complicated than the one we did previously. We know that we should always set out to factor before we do anything else. So x plus 2, x minus 2 in the numerator, and then x plus 2 and x plus 1 in the denominator. And it looks like we are going to be canceling that x plus 2, which means we have a removable discontinuity of x plus 2. So now our function is equal to x minus 2 all over x plus 1. So not only does it help find x-intercepts, find y-intercepts, find vertical asymptotes by factoring first, it also allows us to check for removable discontinuities long before we get anywhere. And we should always check for removable discontinuities first, always factor first. And we see that we have a removable discontinuity of x equals negative 2. So right off the bat, I am going to make a nice circle at x equals negative 2 to figure out what the y value should be, so what the point is for that circle. Plug in negative 2. So we have negative 4 in the numerator and a negative 1 in the denominator, which means we have a positive 4. So removable discontinuity is at negative 2, positive 4. So negative 2, positive 4, somewhere around there. And let's go to, I suppose we can do vertical asymptotes first. So vertical asymptotes, let's do those in red. So first thing we want to look at is vertical asymptotes. That happens where your denominator is equal to 0. So where x plus 1 is equal to 0. So vertical asymptotes are where your function is undefined. So where your function does not exist. And in this case, it's at x equals negative 1. So very close to that removable discontinuity. And remember, we also want to look for behavior around that vertical asymptote. So behavior around there, notice that it's x plus 1 to the first power. So we are going to have our function going in different directions when it approaches that vertical asymptote. So they're not going to be going in the same direction. Let's check out horizontal asymptotes next. So let me change my color. Let's do blue. Horizontal asymptotes. So we want to look at the degrees of our numerator and our denominator. We see that the degrees are the same. So we're going to take the leading coefficients, 1 in the numerator and 1 in the denominator. So our horizontal asymptote is y equals 1. So let's come over to our graph and put down our horizontal asymptote. And you know what? Just to avoid all confusion, remember that you can cross the horizontal asymptote. I am not going to draw my dotted line in the middle. I'm just going to draw it at the ends so that I know that I need to follow it when x goes out to infinity and negative infinity, but in the middle, the function can do whatever it wants. So there's that. Now let's take a look at x-intercepts. So x-intercepts, I suppose we can go back to black for the color. So x-intercepts, where y is equal to 0. So if 0 equals x minus 2 over x plus 1, remember the denominator does not play a role. You can divide that denominator out, or remember that as long as you have 0 in the numerator, no matter what you're dividing by, it's still 0. So we get x equals 2 for our x-intercept, and it's going to cross through that x-intercept because your factor, again, had an odd multiplicity. It was x minus 2 to the first, so it's not going to bounce off of that x-intercept. And I'm going to go over to my graph again, and I'm going to mark x equals 2. And maybe I'm going to put a C underneath to remind myself that I'm going to cross through that. All right, here we go. A couple more things. We need the y-intercept. So y-intercept happens when x is 0. So y equals 0 minus 2 all over 0 plus 1, which equals -2. So the y-intercept is -2. Coming back to my graph and putting a nice y-intercept there at -2. Let's see, do we have enough information? And I think that we do. So remember, like I said in the last one, if you don't feel, if you don't like pulling all these puzzle pieces together, if you don't think it's enough information, if you're still kind of questioning if you have everything, make a table of values and just start plugging in random x values that you think will be of assistance. There's nothing wrong at all with doing that. So given what I have, I'm trying to put my graph into the center there. So I know I like to work from the edges. So I don't want to work from the middle. Sometimes that's helpful, understanding where I need to go from the edge, but it's easier to start out on the edge. So I know I need to follow this horizontal asymptote. I also know that I have to cross this x-intercept. And that's the only place on this graph that I'm allowed to cross the x-intercept, or allowed to cross the x-axis. We need to come down and hit the y-intercept, and then I have to follow the vertical asymptote. And I can't go back up because that would require crossing the x-axis, which I know I can't do because I only have x equals 2 for an x intercept. So instead of turning back up, we are just going to follow that vertical asymptote down. And then I know that I have to be going in opposite directions around that vertical asymptote. So if I'm coming down here, then I need to be going in the upward direction over here. And I know I have this removable discontinuity that I need to hit. And then I need to follow, this horizontal asymptote out. And I can't cross the x-axis anywhere after that removable discontinuity. So that's all there is to this graph.